Binary search. Alright, so binary search is a searching algorithm which requires, or rather, would really like to have a sorted array before you start applying it. Because the basic principle of it is that you want to progressively split your array into half and then go down one of those halves to continue splitting it down until you find your element or you've exhausted your array, which would mean your element is not within that array. So here's a basic example of how you would do a basic binary search function problem. So you have a sorted array of distinct integers and a target value, and you want to return the index. So first what you want to do is find your midway point and then check that against your target. So if your target is your midway point, then you're done. But otherwise, you would want to know if you should go left or go right. So to do that, you would simply check your midway point against your target. And if your target is greater than your midway point, then you know that all numbers to the left of your midway point are similarly lesser than your target. So you don't want to waste time searching through those since they're all going to be lesser than your target. So you can discard that half of your array. Similarly, if your target is lesser than your midway point, then all the numbers to the right of your midway point are going to be greater than your target as well. And so you should discard those. So you would repeat this process multiple times until you either find your target or you find a position where your target is. So find peak element. So we're given a array of random numbers, but we know that two numbers consecutively would not equal each other. So we can have multiple peaks here since it's just random numbers, and we can return any one of those peaks. So this allows us to leverage binary search, since we can simply see if your midpoint is a peak, and if it's not, just go left or right. So the decision to go left or right would really depend on how your numbers are laid out. So you can see here that numbers form like multiple little slopes where this goes up, then this goes down, and then this goes up again, and then from here to here it goes down. So leveraging the fact that these slopes exist, we go discard half of your array depending on how the numbers are sloped. So in order to find your peak, you would check if your halfway number, is greater or less than one of the numbers to the side of it. If one of the side numbers is greater than your halfway number, then that's the point of increasing sloping. So you would follow that half of it. And then you would repeat this until you find your peak where numbers on either side of your halfway point are strictly lesser than it. Right, so in a rotated sorted array, it's in order, but then it's been pivoted by an unknown variable. So it's going from something like this to this. So in order to find our target integer, or rather to check if it's in it or not, we would simply apply our basic binary search principle where we split it into half, and if it's there, we return it. But if it's not equal to half, then we would want to find if the number's in our upper half or lower half. But keeping in mind that the array is pivoted, we would want to see if your number you're looking for is changed according to the pivot. So here we see if the minimum, which in the first iteration would be the 0th number, is greater than our halfway point. So basically, this is checking if the pivot had made it so that your minimum is now greater than your halfway point, so which means the end of your array has been shifted to somewhere in the beginning. So if that's the case, then you know that your target value should be in the upper or lower half, depending on how its comparison with your halfway and the maximum. So then you would repeat this until you either find it or simply not in the array, where in which you return a -1. So all binary functions essentially use a similar kind of methodology where you split your array in half and then you simply divide down the array depending on whichever search condition or criteria you're trying to go for. And yeah, that's binary search.